This topic is about how you managing and processing packet file using DuckDB. Okay, these are 4 topics I'm going to talk about. The first one is packet file using DuckDB introduction. And the second one is simple geospatial data engineering with packet file. And the third one is using packet file with a DuckDB file. And the last one is I'm going to show about DuckDB use case. Okay. What is packet file? The packet file is an open source data file format that is a column-based file format. Okay, and is widely supported across the data ecosystem. You can use packet file on DuckDB, Spark, Arrow, Pandas, and much more. And the packet file is good for compression with the C standard. The documentation is on the link down below. And what is DuckDB? DuckDB is an open source in-process analytical database that is designed for the fast analytical query on the large dataset with a minimum setup. Okay, so DuckDB is the strong point of DuckDB is designed to be simple and beginner friendly and easy to use. So DuckDB is a high performance query execution and is support the columnar format such as Parquet and CSV. Okay, this is the comparison in the file size wise. So the original data is GeoParquet file. So the dataset is approximately around 4.27 gigabytes. And after I convert this GeoParquet file into the Parquet file, it's reduced to 1.86 gigabytes. The dataset is contain about 19 normal attribute column and 1 geometry column with approximately around 3 million records. And the conclusion is the result of the compression is reduced around 56% in storage size. Next one is the comparison about the performance on the scenario of scan all record. Okay. In this GeoParquet, for the scenario of scanning all the record, GeoParquet file is take around 31 seconds, as you can see, and the Parquet file is used only around 8 seconds. Okay. And the next one is the comparison on the filtering query. This is the comparison on the GeoParquet file. It take 14 seconds, but in the other hand, the Parquet file is used only 43 milliseconds. Okay. The query is in this comparison, I query with select only 2 columns and using where-code filtering. Okay. And the next one is the comparison on the library performance. In this comparison, I compare between GeoPandas and DuckDB. Okay. So in this scenario, query is the query of the intersection of the polygons around 240 polygons. Okay. And when I am using GeoPandas, it took around 75 seconds, but in the other hand, the DuckDB using less than 1 second in the same dataset and the same environment. And this is the results, query result. As you can see, this I query with the polygons, the rectangle polygon, and I use that polygon to intersect with data in my dataset, and this is the result. Around 240 polygons that is truly intersect. Okay, the next topic is simple geospatial data engineering with Parquet file. Okay, how you can manage your Parquet file. Okay, this is the simple example. Okay, so DuckDB is designed to be beginner friendly and easy to use. So if you know MySQL, if you already know MySQL, you can use it. Right ahead, it's easy. Okay, the syntax is totally not different from the MySQL. So in this code, it's just it's just convert the GeoParquet file to the Parquet file format. Okay, so this is how you can cleansing your data. So it's just you just need to select the data that you interested in, and it's gonna reduce the file size. Okay, this is the introducing of the high partitioning. So this can reduce the I/O of the query. So it's helping when you query the large data set. So for example, if you have the 10 billion record, right, and you have in this table, if you have the value of the year, month, something like that, and it's gonna, if you partitioning by the years and months, it's gonna be like this. So in the years, it's gonna separate each month that partition by year. Okay. Okay. This is the example of the code. You can have a look in the links below. And when you query with the high partitioning, the code is like this. Okay. So the conclusion is, if you know MySQL, you can use DuckDB. Okay. This is the example of the DuckDB extension. So this one is the spatial extension. It's pretty similar to the podcast. Yeah. As you can see, this one is the intersection function, and this one is the intersect that return true if the geometry is intersect. You can take a look in the links down below. And the next topic is how to use the Parquet file with the DuckDB file. Okay. This is the simple use of the Parquet file used with DuckDB file. After you create a DuckDB file, you can query the data in the same way as the Parquet file, but through the database instead. Okay, so DuckDB can read the Parquet file. Okay, so this one is you create a table by using the data of the Parquet file, and yeah. So the good part of the DuckDB is you can create the index, the geometry index. So when you query the geometry columns, it's gonna be faster. Okay, this one is the use case. Okay, in this section, I will demonstrate what DuckDB can do. So, okay. So in this case, in this code, I have the point is the geometry point that I'm gonna extract the geometry, and I'm gonna use this point to query my data in my data set, if there is any data on that point or not, and I'm gonna plot that into a map. Yeah. As you can see, the point earlier is the point. This point is around here, and it show that it have the data in the data set, and I use that data in the data set to plot a map. Okay, this is the project that I have been working on. So in this project, I have the website is you plot the map on the website, and it's gonna show that is intersect with these 6 forest type or not. So the dataset is having the 6 dataset, and the size of it is around 4 gigabyte. The largest one is the 1.5 gigabyte. Okay, in the next one, the next one is gonna be the comparison. But this comparison is based on my personal experience and specific use case. Result may vary depending on the data and environment. Okay, earlier I used in this project, I used MongoDB before, and it took around 1 second to get the result, to respond. But I switched to Packetfile and DuckDB, and it take only 27 milliseconds response time. Yeah. This is the load test that I have been done before. Okay. The average request per second is around 4 requests per second, but the result that is include the network latency and remote database access overhead. Sometimes the traffic can be spiked like this. Okay, and the average response time is around 10 seconds with the 30 virtual user. Okay. And this one is the load testing of the DuckDB. Okay. The result is I have around 120 requests per second, and the average response time is around 250 milliseconds. Yeah, and at the 30 virtual user is the same 10 minutes load test. Okay, in 10 minutes, DuckDB can send a request to around 71K, okay, 71,000, okay, with no fail. Okay, this is the environment of the load testing. So the spec I'm using is the Apple M4 with the ARM64, okay, with 30 virtual user with 10 minute load testing duration, and the resource usage is using only around 2.5 CPU core and 8 GB of RAM. The overview of result from MongoDB to DuckDB. The request per second is moved to 5. From 5, move to around 120. Is 60 times better, based on my experience. Okay, and the average response time from 10 seconds is moved to around 246 milliseconds. Okay. When you can use DuckDB, when you have when you need to do the fast analytical and your data is not changing a lot, okay, and your workload are heavy, you can use DuckDB. But I think when not to use DuckDB is when you need to do the real-time update by user. Okay, and when you often change the data in database. Okay, and when you need high concurrency transactional overload. Okay, that's it for my presentation. Thank you.
Yeah, do we have any questions? Yeah.
Thank you for the presentation. I just want to know, you showed one slide where you have used Hive to distribute the database across the multiple nodes.
This one?
Yeah. So, what sort of sharding strategy have you implemented in this?
Again?
What sort of a database sharding strategy have you implemented in this?
Database?
Any data sharding strategy have you used in this? Like, how have you split the data across these nodes?
Oh, okay. This is partitioning the year. Is this is distribute the year into the month,
Okay.
and this one maybe is up to your data. Maybe it's a day, something like that.
All right.
Is it the answer you
Fine.
expect?
Okay. Okay. So is it, okay, fine. It is not implemented for one date as of now?
Yeah.
Thank you. Fine. Thank you.
Yeah, anybody else? Yeah, all right. Thank you.
Okay. Thank you.